All right, guys, so today we are going to do memory. We're going to start memory, which is the first part of the cognition unit that we will continue on after winter break. So I highly suggest that if you haven't printed out this PowerPoint presentation, then to follow along with the notes that I attached and I handed out to you guys on Monday. The notes completely follow the PowerPoint, and I'm a big proponent of writing everything down. It will help you remember it a lot easier. It's very easy to follow. So let's get started. So first we're going to look at the physiology of memory. So we're going to hop all the way back to the biology unit that we did so long ago in September. And we're going to talk about some of the different parts of the brain that have to do with memory. The first, we're going to talk about anatomy, then the neural circuitry, and then biochemistry. So first, let's talk about the anatomy. So the amygdala, we're going to bring the amygdala back up again. I know you all love to say it because it's a super weird word. The amygdala controls fear and aggression, but it also has a huge part to do with emotional memory as well. And then the hippocampus and the cerebellum are kind of the two big ones here. The hippocampus, think back to the goofy video we watched and the guy who had the hippo. He couldn't find campus. He was walking around on campus. He couldn't find his way. Hippocampus has to do with forming long-term memories, personal memories and factual memories. So personal memories, like I remember, the day my sibling was born, or factual memories, like basically everything that you're learning in AP psychology. And then finally the cerebellum, which you guys know and is correct, has to do with balance and coordination, but it also has to do with learning procedural memories. So playing a sport, learning how to dance, all of those things are learned and stored in the cerebellum. So how to physically do things, how to tie your shoe, how to brush your teeth, all of that's in the cerebellum. Here's just a reminder of where everything is. Cerebellum's in the back, hippocampus and amygdala sit right on top of it in the center of the brain. So let's move on to neural circuitry. So think back to action potential. Think back to when we went outside and we made the giant action potential chain outside of the room. So neural pathways are interconnected networks that are used for storage and retrieval of memories. So basically, the healthier and the more neural circuits and neural pathways that you have, the better memory you will have. So the more connections that we can make, the more pathways that we can make between pieces of information, the easier it will be for you to retrieve information. That's why I try and bring so many of the different units of study into one another, so we can connect all those pathways and memory is more easily available to us. When it is more easily available to us, we get long-term potentiation. All of you have experienced long-term potentiation. Think about when you sit down to do your homework or when you sit down to do a test and you're like, okay, I'm focused, I'm ready to go, like bing, bang, boom, I have it all done. You're totally in the zone. Versus times when you sit down and you are like, nope, I can't do this right now. This is not happening. So you're experiencing long-term potentiation when you're in the zone and you are experiencing extremely efficient learning. Your synapses are firing so efficiently. Memory and thought is going very quickly and, very well. It's basically, I can get there after I've had about 3 cups of coffee. So first period never really experiences that from me. So next we go to biochemistry. We've talked about serotonin time and time again and its relation to depression, and it's little known, it also has a lot to do with memory. So depression, when someone has depression and they have a lack of serotonin, they also have a lack of encoding ability. It's a lot harder for them to encode memories and information. So you have to remember that serotonin is not only linked with depression, but memory as well. So we're going to go into the nitty-gritty of it, the 3 stages of memory. And people have come to call it the information processing model, and they compare us and our memory to a computer. And this is the easiest way I can tell you to do it. There's 3 different parts to memory: encoding, storage, and retrieval. And the way it relates to a computer is encoding is getting the information, like typing it into a keyboard. It is physically the recording of the information. It's us taking notes on the keyboard, okay? Next is storage. That's the second processing that we do for memory. And that would be like the clicking save button. So you're typing up an essay and you click save, you're storing it. You're storing it into the computer's hard drive, or you're storing a memory into your brain. So we're thinking parallel, computer and brain. Third, we get to retrieval. Retrieval is when it's time we want to pull that memory back out, or we want to pull that file back out. So we, control open, and we pull out the file that we want, print it, and hand it in for a perfect score, of course. So think about the computer, the keyboard, the save button, and the open button. Encoding, storage, retrieval. Encoding, we're putting the information in. Storage, we are encoding it and storing it in our brains. And retrieval, we're getting it out again. So we'll start with encoding. Encoding requires a lot of attention. Encoding, you can't be distracted. So why do I always tell you to put away your phones when we take notes? This is why. And there's two different levels of processing when we come to encoding. There's shallow and deep. Now, shallow processing or shallow encoding is very surface information, like the sound of my voice. You hear the sound of my voice, you're like, okay, Miss Chris is talking, gotcha. But deep level of processing or deep level of encoding would be able to make a connection. So you would be able to take the information I am telling you and connect it to, oh, I remember a time that this, or I remember a graph of this. So it's making the connections. It's connecting the neural pathways like we talked about before. So then we go to three different types of encoding. First, we start with visual encoding. Visual encoding, we want to think about, it's seeing an image. And when visual encoding works, it becomes, and when it, turns into a memory, it becomes something called iconic memory. So it's when we encode information solely based on the images of the information. Some people are visual learners. They can look at a graph, and that really helps them process. Next is acoustic encoding. It's exactly what it sounds like. It's encoding information totally based on a sound. And when acoustic encoding works, it becomes an echoic memory. Third is semantic encoding, and this is the big one. Semantic encoding is the one that works best. Semantic encoding is, it's encoding information to have a meaning. So it's encoding information that is meaningful, and it enhances the recall. So if you look at this graph, it's very clear, far and above that semantic encoding, when you can take information and make it meaningful to you, you are up basically 90% more likely to recognize a word than if you just look at the word, right? So application quizzes, that's my whole idea behind application quizzes. Let's make it meaningful. Let's apply it to something. So there's two different ways we can enhance the encoding process. First, self-reference effect, and this is, kind of what I was touching on before. It's how to make something, information, personally relevant. Semantically encoding information that's personally relevant. That's why I tell you guys all the stupid stories and silly stories from my life, besides the fact that I, like to hear myself talk. I tell you these silly stories to give you, some kind of personal thing to draw from if you don't have it for yourself. But it's the most, and self-reference effect and encoding information will work the best if you can take a piece of information and draw on something and relate it to something in your life and your personal experience. Second way to enhance encoding is spacing effect, and it's something that we all strive for, but usually it doesn't happen because procrastination. So spacing effect is ideally that we would distribute the practice of learning. So, one night you'll watch the first part of this video and take about 15-20 minutes of notes, and then the next day you'll do another 20 minutes of notes until I see you again on Wednesday. Will that happen? Who knows? So spacing effect, it's called, when it works well, distributed practice. So now let's move on to the second stage. We encoded the information, we typed it in the keyboard, so now let's go on to storage. We're going to go to that save button on the computer. And there's three distinct storage systems. You've heard about them all, I'm sure. Sensory memory, short-term memory, and long-term memory. Now, when we go through and we start studying for the AP test, you'll see short-term memory referred to as working memory and vice versa. They are actually, in like psychology, if you go on to major in college, two very different things, but for AP Psych for high school, we use them intermittently. You'll also see this three storage system called the Atkinson-Shiffrin model. It's just some fancy psychologists who thought of these three together for storage systems. So here's a graph. It'll help you out. So first we get a sensory input. We get a sound. We get a smell. We hear something, and it goes into our sensory memory. That's the first stop. Next, if we encode the information properly, it will go into our short-term memory. And if we do that well enough, if we rehearse and do some of these other things I will tell you about, we can store information into our long-term memory. So it goes sensory, short-term, and then long-term memory. So if we start with sensory memory, it's exactly what it sounds like. You take your 5 senses. It's hearing, it's seeing, it's tasting, it's touching, it's smelling something. It's just a very brief initial coding of something, like, oh, I smell, something. I smell something. Maybe someone's making cookies. Someone's doing this. I hear screaming. Something might be wrong. Okay, so it's and there's different kinds of storage. We've got iconic storage, which is visual information, echoic storage, which is sound information. And this information is held just long enough for us to make a decision on its importance. If we hear something screaming, do we do something about it? If we touch something and it's super, super hot, do we pull our hand away? Sensory memory. And part of that is automatic processing. It's the unconscious encoding of some information. It's information on space and time. So, it's you sitting here taking notes and realizing where are you sitting, where is your water bottle, where is your pet, where is a blanket. It's information like that. It doesn't take a lot. Automatic processing does. Another level of sensory memory is effortful processing, though. And effortful processing is encoding that requires attention. So that's school. That's practice and dance class and, sitting and taking notes in any class. That's effortful processing. And finally, parallel processing. Parallel processing is our ability to process multiple sensory inputs simultaneously. So, when you're looking at this PowerPoint slide, you're not doing one sense at a time. You are looking at the slide and listening to my voice. You're not just looking, okay, pause, now I have to play it again and listen to her voice. You can do both at a time. There's so many senses around us in the world, it's impossible for us to only process one at a time. So now we go to short-term memory with our girl Dory. Short-term memory, it's very conscious, activated memory. It holds information very, very briefly before it is stored or forgotten. So short-term memory is the crucial point. If information doesn't make it past short-term memory, we will not remember it. And the magic number here is 7. I want you to write it really big. I want you to put stars around it. I want you to circle it 700 times. Our short-term memory can hold approximately 7 plus or minus 2 chunks of information. So back in the day when we didn't have cell phones, I know I'm not that old, but there were not cell phones when I was in middle school and the beginning of high school. We had to memorize each other's phone numbers, and without the area code, without the 703 or the 412 in my case, it's 7 numbers. So for a very short period of time, you can remember approximately 7 numbers. Now that will go away if it's not rehearsed or if it's not studied. But 7 is the magic number in this case, or in the working memory or short-term memory. Another way to help remember information in short term is chunking. It's the way the worksheet is split up. It's the way I try and split up most worksheets. You kind of organize information into very meaningful units. And more information is able to be encoded if it is organized into meaningful chunks of units. So if you look on at the little graphic I have here, you have a grocery list. On the left is the unchunked list. It's just all of the things that they need in one list: bread, ice cream, milk, tomatoes. But to make it more meaningful and to make it more rememberable, we chunk the food into the specific category. So we go frozen food, ice cream, frozen peas, dairy, and it says diary, so whoever made that, I don't know what was wrong with them, milk, eggs, cream and butter, etc. If I mean rehearsal, rehearsal should make pretty much sense. Think about rehearsal if you go to dance rehearsal, play rehearsal, or practice for all the sports. Yay, sports. It's the unconscious repetition of information in order to encode it. And the more time we spend in rehearsal, the more information we are going to remember. And I'm going to stop you guys at this. This will be the end of our first video. The second one will be up shortly. So we will meet again here at Rehearsal and Retention.